Today we're going to talk about descriptive statistics, which is going to start a series of lectures talking more about the quantitative aspects of standardized testing, and I'm really excited because these are some of my favorite lectures to give. So let's get started. So Statistics Day, yay! So this is kind of a funny cartoon about statistics, so I'll let you read that. Okay. So the first thing we have to do when we're looking at examining test scores is to score the responses to individual items. And we kind of have three different types of item scores to look at. So dichotomous items, remember from our first lecture, are typically scored either 0 or 1, so either incorrect or correct, right? Then we have ordinal scores. Those are scores graded in categories. And think about something like the Florida Writes exam or writing tests graded on a rubric. So we either have like a 4 that's superior, a 3 is good, a 2 is acceptable, and a 1 is poor. And we think about these ordinal scores in that they're equidistant apart. The 4 is equidistant to a 3, equidistant from a 2, equidistant from a 1. But the quality between those isn't necessarily equidistant, but we're making that assumption that they are. And then we have continuous scores. So those are rated on a numerical scale from 0 to 100. And the thing to think about with a continuous score is that theoretically it could be anything in between there. So it could be a 99.5 or a 89.367, right? So there's an infinite number of scores in between on that continuous scale. Typically, we don't see those continuous scores on individual items, but we see them when we put together all of the scores on a test. So just kind of keep that in mind about thinking about individual items if we have dichotomously scored, ordinal scored, or continuous scored items. So we combine these item scores in a couple of different ways. We kind of can do this most simply by adding up the scores on individual items. Sometimes we need to weight those items appropriately, and we do this as teachers, right? If we have an essay question and we have multiple choice items, usually that essay question's worth more points than the multiple choice items. We might have the true false worth differently than multiple choice, short answer questions. So as a teacher, we kind of do this automatically. We think about how much we weight items. Test developers might do this as well. They might make more difficult items worth more points than questions that are easier, or vice versa, right? We can also do this through item response theory. So this is a really technical way of looking at how difficult or easy items are. And ways that this can happen, something like the GRE, or if you guys are familiar with the iReady tests that are used in the district, it's a smart testing system, an adaptive test, so that if I get a question wrong, it gives me an easier question. If I get a question right, it gives me a harder question. So those questions are weighted to give me a score at the end that is really individualized. So I didn't have to give the student all 2,000 items in the testing bank to show exactly what their level is. I only had to give them, I could tailor that test directly to the level that the student was. The GRE is given the same way. So if you go in to take the GRE and you come out and you're like, wow, that test was really easy. Bad news for you, you probably got a bunch of easy questions, which meant maybe you didn't get all of them right. This is what we call a raw score. And then from that, we are going to do we'll get developed some standardized scores. So we usually can't really interpret that raw score. So when we're looking at these descriptive statistics, and usually we base these upon some sort of calculated score, it helps us summarize a large number of scores. And the advantage of descriptive statistics is that it helps us portray these features of a group efficiently, effectively, and easily. So think about this. If I had 200 students and I just had a page of all of their scores, it would be really hard for me to make sense of all that data. But if I can use descriptive statistics, now I can summarize that data really easily, and I can understand what that data is telling me about my students. So there's two ways to look at the frequency distribution. So a frequency distribution is really just the ways in which my scores are counted. So frequency just means to count. So I can have a simple frequency distribution, and this is really just counting how many scores I have of each level. So if we look on the left, you can see over here that I have a count of how many of my people in my sample have each salary, and you can see which salary has the most, and that's 32,000, right? That's 20% of my population, and then coming out from that, on each side 3 and then 2 and then 1, right? So I have a pretty nice distribution here. And now that they're in this table, it's pretty easy for me to see how my salaries are distributed across my sample. The other way I could do this is I could group them. So in this example, I've given you a range of class marks of grades, and I've shown you how many people are in each group. So this is helpful. Let's say that if I wanted to see, how many students had A's or B's or C's on a test, this would show me really easily. And you can see here that most students scored between a 31 and a 40 on this exam, right? So we can either have simple or grouped frequency distributions. And frequency, again, just means counting, right? Frequency is counting. And then we can graph these frequency distributions in 2 ways, either through a polygon of scores or a histogram. And a polygon is really just graphing how many we had at each score point. So it's really like that simple frequency table that we saw before, and you can see, I had about 20 people at 55, I had 60 people who had 65, I had 100 people who scored a 75, you can see. So the area under this curve really shows me how many people who scored at each level, right? A histogram is more like that grouping frequency distribution that we saw before, and this is really just a bar graph of how many people, the number of employees at each range of scores. So we had over 500 who had a salary between $44,000 and $54,000. Does that make sense? So the height of each bar tells me how many people we had at each range of salaries. These are important later on when we start looking at the normal curve. I really want you to understand that the area under the curve is telling us how many students, how many people are at that number on the test score. And when we look at these frequency distributions, we can see how it can have a positive or a negative or normal distribution. So in this normal distribution, we can see that we kind of have the same on each side. It's equal. We have the same, my middle score here, we kind of have the same that are more or less than that middle score. In a positive skew, we have a lot of people right here in the middle at the highest level, but we have a lot more that scored higher than the most students. And we kind of have the opposite here. The most students scored here, but then we have a lot of people who scored underneath that. So we call a distribution that looks like this a positive skew because we have more area on this positive side. We call this one a negative skew because we have more people who are on this negative side. And we can also look at how tall or flat it is. So in this one, it's more distributed. We have more variance because it's really flat. If you can imagine in this normal distribution, we have less variation. More people are kind of closer to this middle score. So when we think about the frequency of our scores, our distribution of scores like we call it, we can think about how it might be positive or negative. We can think about how it might be more varied or less varied. And all of this is important when we want to summarize what our students' scores look like on a test. And this normal distribution becomes really important as we start talking about norm reference test scores in our next couple of lectures. So look at this normal distribution. This is a normal distribution. You can see that is pretty even on both sides. And then we'll talk about standard deviation and a couple of things in a minute. But what I really want you to understand is that the area underneath this curve is the number of students that scored at each level. So we have the most number of students who scored right in the middle here, and an even number of students who scored more or less than that middle. So let's talk about measures of central tendency. When we talk about measures of central tendency, what we're talking about are ways in which we can summarize what the typical student does. So central tendency means what this typical student is. It's the first measure of central tendency, and some of this is going to be a review for you guys. So hang in there with me, guys, if you're like, oh yeah, I remember this. So the first one we'll talk about is mean, right? And mean is just another word for average. So we calculate the mean by calculating the average, right? So that is the sum of the scores divided by the sample size. So you add up all of the scores you have, and then you divide by the number of students that you had, right? The median is the midpoint of the distribution. So you put all of your scores in order from lowest to highest, and then you find that middle score. If you happen to have an even number of scores, then you take the average of the two scores in the middle. And then the mode is the score that occurs the most frequently. In general, we have the least use for modes. So we'll talk a lot about mean and median in describing measures of central tendency. We talk a lot less about mode. This is really important. When we're looking at this normal distribution, remember this chart from before? In a normal distribution, all measures of central tendency, the mean, the median, and the mode are all the same, which is really cool, and that's why this normal distribution is really important. So let's take a minute to unpack this, right? So we can see the mode here, the most frequent score, right? The highest point in this curve is right here. It's right in the middle. That's the median, right? It's the same on both sides, which means it's also the mean. So the average score, the median score, and the mode are all the same in the normal distribution. And that becomes really important for analyzing these scores later. So I like this rhyme if you're going to be teaching this, these measures of central tendency to your students. Maybe if you're teaching elementary math or even middle school math, you might want to learn this. So I'll let you read it to yourself. I think it's pretty clever. The other thing that we want to talk about today, in addition to measures of central tendency, are measures of variability, which we also call measures of dispersion. So these are ways in which we're not just concerned about what the typical student looks like, central tendency, but we're also concerned with how much is that typical student, how much do most students look like that typical student? So that's variability. How variable are our students when we're looking at that? Are they all pretty much like that typical student, or are they all really different from each other? So the first and the easiest measure of variability is range. And range is just the spread of scores, so the difference between the highest and lowest score. However, range can be pretty inaccurate because it's really sensitive to what we call outliers. So outliers are scores that are the most different, right? So let's say that all of my students scored, a 50 on a test, but I had one student, there's always one student, right, who scored a 100, another student who scored a 0. My range would be 100 points, right? 100 minus 0 is 100. But most of my students scored a 50. So I'd have a really big range, but still most of my students were pretty close to each other. So range is really easy to calculate, but it doesn't always give us an accurate picture of the variability of our students, right? Which is why a more accurate measure of variability is what we call standard deviation. And I know some of you are having some flashbacks to your stats class in high school, and you're like, oh gosh, this is really hard. The good news is I'm not going to ask you to calculate standard deviation. I just want you to understand what standard deviation is and why it's important. So standard deviation is the average deviation, or the average distance of the scores from the mean. So how far is the typical student from the average? Does that make sense? So I've told you, here you can see steps 1 through 6 on the slide. This is how you calculate standard deviation. And you get these square roots and the squares in here because we want to have the absolute number. We want to take care of negatives and positives when we're taking those subtraction differences between the student and the mean, right? But basically, you calculate the difference of every score from that average, and then you take the average of those differences. It's the basic way to calculate standard deviation. And the good news is if you're using Excel or any other kind of data software program, they'll do it for you. So I'll show you later on how to calculate standard deviation in Excel. Super easy, so you don't have to do it by hand. But I really want you to understand that standard deviation is the average distance from the mean of each score. And we're going to be using this when we start talking about how to interpret standardized scores and norm reference tests. So standard deviation actually becomes pretty important. Okay, so why might it be important to understand the variability or the dispersion of your data? So let's look at these pictures here. So you can see here's some different distributions, right? So here's this normal distribution, right? Okay, but if we look at these over here, we see really different patterns of the distribution of our data. And actually, these patterns right here are pretty common in a classroom test. What we see here is we have a bunch of students over here who understood the test, and a fair amount of students over here who did not understand. And we see this pattern a lot in our test scores in a classroom, right? We have a group of students who did well on the test and kind of a group of students who didn't do well. And so we want to understand the variability. We have much more variability here than we do here. Even though the mean of these two groups might be the same, right? It's kind of right here in the middle. The variability is going to be much different. There's much more variability in this picture than there is in this picture. And that's why it's important to not just look at central tendency, but to also look at variability. So I'm going to run through a couple of examples again just to kind of show you what mean, median, or mean, standard deviation, and range kind of look like in some different examples. So if I have 50 students who scored a 100 and 50 students who scored a 0, what's our mean? What's our range? And what's our standard deviation? Okay, good. So our mean is 50, right? Our range is 100, and our standard deviation is 50. Everybody get that? Let's get a different example. So in this example, 100 students scored a 50. I should say, and yeah, all of our students scored a 50. So what's our median? Our mean, right? What's our range? What's our standard deviation? Yeah. So our mean is 50, our range is 0, our standard deviation is 0, right? So look at these. In these two examples, our mean is the same, but our range and our standard deviations are really different. So even though our average is the same, we see really different measures of variability. Let's look at one more example. In this example, one student scored a 100, one student scored a 0, and 98 students scored a 50. So what's our mean here? What's our range? And what's our standard deviation? Close to, an approximation. Okay, good. So here, our mean's the same, right? Our mean's still 50. Our range is 100, right? 100 minus 0 is still 100. So we see the same range here, but our standard deviation's approximately 0. It's really close to 0. So this gives us a different picture. So by looking at these mean, range, and standard deviations, we're seeing really different pictures of our students' data. So it's important to think about how central tendency and measures of variability can show us better pictures of descriptive statistics of our students' data. Okay, so here's an in-class activity that you can do. Make sure that you at least know how to attack and solve this problem. And if you don't, be sure that you send me an email and I'll be happy to meet with you either on the phone or in my office to go over how to solve this problem. In the meantime, have a good day, and I look forward to seeing your work this week. Bye-bye.